Welcome to G Fun Facts Online. Imagine you're stranded. Your car has broken down on a remote mountain road, or you've taken a wrong turn on a hiking trail, miles from the nearest cell tower. Your phone has no signal. For decades, this scenario could have been a death sentence. But today, a silent revolution is unfolding in the palm of your hand. With just a few taps, you can send a distress message, not to a cell tower, but to a satellite orbiting hundreds of miles above the Earth. What was once science fiction, or a tool for spies and elite adventurers, is now becoming a standard feature in the phone you carry every day. Today, we're diving into the unseen network in the sky and how it's becoming an everyday lifesaver. The need to call for help is as old as humanity itself. Ancient civilizations used signal fires, smoke, and drums. Later, church bells and fire bells warned entire towns of danger. You might remember the famous prearranged signal from the American Revolution. 1, if by land, and 2, if by sea. But the 19th and 20th centuries brought a technological explosion. The telegraph allowed near-instant communication over vast distances. One of its earliest emergency uses was in 1907 to report a train robbery, leading to the criminal's arrest. Then came the tragedy of the Titanic in 1912. While a terrible loss of life, it was also a landmark moment for emergency communication. The distress signals CQD and the newly adopted SOS, transmitted by the ship's wireless operator, summoned the RMS Carpathia, which saved over 700 lives. This single event spurred new international laws, making wireless communication a mandatory safety tool at sea. As technology progressed, we got telephones and radios. By the 1960s, a new problem emerged. In an emergency, who do you call? There was no single number. You had to know the specific number for your local police or fire department, which caused dangerous delays. The United Kingdom had established the world's first emergency number, 999, way back in 1937. The US followed suit in 1968, when AT&T designated 911 as the nationwide emergency number, chosen because it was simple and wasn't already in use as an area code. The very first 911 call was made in Haleyville, Alabama that same year. The 911 system was a phenomenal success, but it had one major limitation. It relied on terrestrial networks. What happens when you're beyond the reach of any phone line or cell tower? That's where space comes in. The idea of using satellites for search and rescue gained serious traction after tragedies at sea and in the air. The sinking of the Titanic had already shown the limits of land-based wireless. In 1979, the International Maritime Satellite Organization, or Inmarsat, was established with a primary mission to use satellites to protect the lives of seafarers. But another tragedy pushed the technology even further. In 1970, a plane carrying 2 U.S. congressmen crashed in a remote region of Alaska. No trace of the aircraft or its occupants was ever found. This led to a mandate that all aircraft carry an emergency locator transmitter, or ELT. The problem was, these early beacons weren't designed for satellite detection. This spurred the creation of the COSPAS-SARSAT system in 1979, a joint effort by Canada, France, the United States, and the Soviet Union. COSPAS-SARSAT used satellites to specifically detect and locate distress signals from emergency beacons on planes and boats. Its first credited rescue happened in September 1982, when it located a small downed plane in British Columbia. Since then, the system is credited with saving tens of thousands of lives. These systems, using devices like EPIRBs for ships and ELTs for planes, were a massive leap forward. But they were still dedicated, often bulky and expensive pieces of hardware. The true democratization of this life-saving technology would have to wait for the next great leap, putting that power directly into the smartphone you already own. So how exactly do you get a small, low-power smartphone to talk to a satellite hundreds of miles away that's hurtling through space at 17,000 miles per hour. It's a monumental engineering challenge. Your phone's transmitter is designed to reach a cell tower a few miles away, not an object in orbit. The signal that reaches the satellite is incredibly weak. To solve this, companies had to develop new, highly sensitive receivers and advanced antennas on the satellites themselves. They also had to design new chipsets and modems for the phones that could transmit a signal powerful and focused enough to be heard. Then there's the Doppler effect. Because the satellite is moving so incredibly fast relative to you on the ground, the frequency of the radio waves gets shifted. Sophisticated signal processing software is needed on both the phone and the satellite to constantly adjust for this shift and maintain a lock on the signal. Finally, there's the problem of coverage. A single satellite can only see a part of the Earth at any one time. To provide continuous service, you need a whole network or a constellation of them. This is why companies like Starlink and Globalstar have launched hundreds or even thousands of low Earth orbit or LEO satellites. These mega constellations ensure that no matter where you are on the planet, there's almost always a satellite overhead and ready to connect. The final piece of the puzzle was integrating this capability directly into the phone's operating system, like Apple's iOS and Google's Android. This allows the phone to automatically detect when there's no cellular or Wi-Fi, and seamlessly offer the option to connect via satellite. This new era of direct-to-device satellite communication is being driven by a fascinating ecosystem of tech giants, satellite operators, and mobile carriers. In 2022, Apple fired the starting gun with the launch of its emergency SOS via satellite feature on the iPhone 14. Partnering with the satellite operator Globalstar, Apple created a service where, if you try to call 911 with no signal, the phone prompts you to text emergency services via satellite instead. It even includes a graphical interface that helps you point your phone directly at the satellite in the sky to get the strongest connection. Not to be outdone, T-Mobile announced a blockbuster partnership with SpaceX's Starlink for a service they call Coverage Above and Beyond. Their ambitious goal is to turn Starlink's second-generation satellites into cell towers in space. These satellites are equipped with special modems that allow them to communicate directly with many existing smartphones, without the user needing any specialized hardware. The service started with text messaging and aims to add voice and data capabilities in the near future. Then you have Verizon, which has thrown its weight behind a company called AST SpaceMobile. This company is building a space-based cellular network with satellites that feature enormous phased array antennas. Their test satellite, Blue Walker 3, has the largest commercial communications array ever deployed in low Earth orbit. With a $100 million commitment from Verizon, they plan to provide full satellite-to-phone connectivity for voice, video, and data in cellular dead zones across the US, targeting a commercial launch in 2026. And we can't forget the pioneers. Garmin, long a leader in GPS devices, has offered its inReach satellite communicators for years. These devices use the Iridium satellite network for two-way messaging and have a dedicated SOS button that connects to a 24/7 emergency response center. Garmin's experience is so valued that they've now partnered with Google to provide the emergency response backend for its new satellite SOS feature on Pixel phones. This technology isn't just theoretical. It is actively saving lives right now. The stories are both dramatic and inspiring. In one case, a mountaineer suffered a wrist injury while descending a remote mountain. With no cell service, he used his iPhone's satellite feature to send a distress message, leading to his rescue. In British Columbia, 4 hikers were cut off by a raging wildfire. With embers reportedly falling on their tent, they used Apple's emergency SOS to guide rescuers to their exact location. The service has also been invaluable in car accidents. One man's car went off a 400-foot cliff in a remote canyon. His iPhone's crash detection feature automatically triggered the satellite SOS function, alerting emergency services to the crash and his coordinates. Search and rescue teams have called this combination a game changer. And it's not just for dry land. A woman and her dog were swept away by a flash flood in a Utah canyon. Tumbling in the muddy water, she managed to use the satellite feature to send her GPS coordinates, allowing rescuers to find her 2 miles from where she started, shaken but unharmed. The veteran in this space, Garmin's InReach, has an even longer track record, with over 10,000 SOS incidents recorded by late 2022. And the potential extends beyond individual rescues. During Hurricane Helene, when cell towers in North Carolina were knocked out, T-Mobile received special permission to use Starlink satellites to broadcast emergency alerts directly to phones in the affected area, a breakthrough that could bring life-saving warnings to the 500,000 square miles of the U.S. that currently lack cell coverage. So, what's the business model? How can providing a life-saving service be profitable? Apple has taken a unique approach, offering its emergency SOS feature for free for at least 2 years with a new iPhone purchase, a period they have since extended. This helps differentiate their product and drives adoption. They can monetize the underlying technology through other paid services, like the roadside assistance via satellite they've already introduced. T-Mobile, on the other hand, is offering basic satellite text to 911 for free to anyone with a compatible phone, even if they aren't a T-Mobile customer. More advanced features, like two-way messaging with friends and family, are included in their premium plans or offered as a paid add-on. This strategy both provides a public good and creates an incentive for customers to upgrade or switch carriers. For the broader industry, GSMA Intelligence estimates that direct-to-device satellite services could be a $30 billion revenue opportunity for telecom companies by 2035, by filling coverage gaps and offering premium connectivity plans. Despite the incredible progress, the road to truly ubiquitous satellite connectivity isn't perfectly smooth. There are significant challenges. The use of satellite radio spectrum is highly regulated by bodies like the FCC and international unions. Companies must navigate a complex web of rules to prevent their satellite signals from interfering with existing terrestrial cellular networks. Technically, integrating powerful antennas into sleek smartphones remains difficult, and the service still requires a relatively clear line of sight to the sky. Dense forest canopies, canyons, or even just being indoors can block the signal. The limited bandwidth also means most services are currently restricted to short text messages. However, the future is incredibly bright. The trend is towards more capacity, more reliability, and lower costs. We are already seeing the expansion from purely emergency SOS to two-way messaging with friends and family. The next frontier is voice, and then data, which could eventually lead to a truly global mobile network where you can stay connected no matter where you are on Earth. The ultimate goal is a seamless integration with 5G and future 6G networks, where your phone will intelligently switch between terrestrial and non-terrestrial networks without you even noticing. The societal impact is profound. For anyone who works or plays in the great outdoors, it provides an unprecedented level of safety. For those in rural areas, it's a vital link to the outside world. And in the face of natural disasters that can cripple our ground-based infrastructure, it's a resilient lifeline for everyone. The democratization of emergency satellite services is a testament to our relentless pursuit of a more connected and safer world. The journey has been long, from the first flicker of a signal fire to the sophisticated dance of satellites in the sky. But what was once a technology for a select few is now becoming a silent guardian in all of our pockets, ready to ensure that no matter how far we roam, no call for help goes unanswered.